Yes, I know there's a lot to know about SQL in general, but in reality, at work, there are only a few parts of SQL that are used all the time. So now, in this video, I will show you what parts of SQL are needed frequently in the daily work of a data analyst. Now, to make things more fun, there is a story underlying this video. It's linked in the description if you'd like to watch it, but it's also completely optional and you'll do fine just by following this video. And the story goes like this. A beginner data analyst, Jay, gets a very typical request to pull some data. He calls a data engineer who helps him. As they work together, they use exactly those parts of SQL that are needed frequently. Or, in other words, the story follows a typical workflow. And that's why the story is useful for you to watch. Let me show you now what is this typical workflow. Here we have 6 steps of that workflow, and some parts are in gray because they are specific to the kind of database or tools that you will be using at work. In my story, I was using SQLite in the terminal because I had my own reasons for it. But you will have to learn it depending on how exactly you will be working. And for you, it will most probably be something else, not SQLite and not terminal. Other steps, 3, 4, and 6, are much more universal, and 3 and 4 are about SQL language itself. And SQL is pretty much the same no matter what database or tools you're using. There are just some minor nuances. So now, in the rest of this video, I will reproduce those steps in my terminal, explaining everything as I go, step by step. That will give you the foundation, and from there you should go and learn those steps in depth. Okay, our story begins and they start by opening the database. And as soon as Jay types his very first line, he makes a mistake. This, SQLite 3, is the command to launch embedded SQLite, then space, and then the database file. So in SQLite, the whole database is basically stored in a file. And when you open that file, you open the database with all the tables and all the data. Now, how does SQLite find this file? It looks for it in the place where it is at the moment, or in the working directory. Yeah, its current working directory or current folder. How do we know what is our current working directory? Well, we ask pwd for print working directory. And we are here in our home folder. So we are right here. But there is no database file here, and SQLite will not find it. So because Jay downloaded the file, it's actually sitting in downloads here. And he's not specifying how to get to the file. He's just typing SQLite 3 and data db. When I execute it, everything looks okay, but in reality, SQLite did not find the file and instead created in the transient in-memory database. And as soon as I will ask something of it that will trigger a so-called write operation, it will create a file. So for example, what Jay does is he wants to check what tables are in the database. And so he types this command dot tables. SQLite, in order to have a look what tables are in the database, has to first make sure that the file exists. And of course, in our case, it doesn't, so then it creates the file. So watch what happens when I execute this. Look right here. I execute, and you see another data file has just been created with that write operation. And of course, this data file is empty. And here's the write file. It is 41 kilobytes. That's the correct file, but we are currently having our empty file open. And of course, when we asked what kind of tables are there, we got nothing because there's no tables there. So to do it the right way, we would have to, if we did it from the very beginning, type like this, SQLite 3, and then give it the path to the file like this. Downloads and then data db like this. And now if we ask what tables are there, we get the correct list, 4 tables in the database. There we go. In the story, it happens slightly differently. I'll show you that other way as well. So in the story, first they open the wrong file without the path. I can see no tables. So now we are here in this empty file, but then we can open the right database on top with a command open.open, and then we give it the path datadb like this, and it will forget about this file and open that one. And now let's check for tables, and we will see our 4 tables correctly. See, now we can get rid of this empty file. The next step in our workflow is to look at the tables and the contents. And we already looked at the list of tables with this .tables command. So now we know that there are 4 tables: extras, extras provided, invoices, and stays. But what data is in there? And in the typical data analysis workflow, people usually look at the first 5 rows of a table to understand what it's about. This is done with a select statement of SQL language. That looks like this. So for example, I want to look what kind of data is in table stays. I write select everything from stays. And usually we also limit how much data we want to look at, and for some reason this is typically first 5 rows. I don't know why. Sometimes last 5, but typically first 5. So to limit to the first 5 rows only, we just add a limit and then 5 and the semicolon. And there's the result. Here are the first 5 rows, and here this looks not quite nice. We will fix that in a minute, but I just want to make a quick note of one thing. Notice that here I was beginning commands with a dot, and here I'm not beginning with a dot, but I'm ending with a semicolon, and it's a syntax thing. So this is a typical SQL language grammar or syntax, where you simply write sentences like this and you end them with a semicolon. But the other commands here are actually not part of SQL language. They are part of SQLite commands. So to distinguish between them, they are preceded by this dot and they don't need a semicolon at the end. Just keep this in mind as you watch me do things. Here, also look at this prompt, SQLite. This means that we are in the SQLite environment where it expects SQL language from us, or SQLite commands distinguished with a dot. So we have this not such a nice display, and to adjust how SQLite shows the data to us, we have another SQLite specific command called mode. So dot mode and then space, and then you specify what kind of mode you want. Now, if we don't really remember what kind of modes are there, actually we can always use another command, very useful, .help and then space, and then whatever we want the help about. We want the help about mode. So then it's like this. And we have possible modes. Actually, I haven't even tried most of them. Why not I try them now? I will speed this up for you. Okay, mode C. And then I repeat the select statement by just pressing the key up or down. I can go through the history of my previously executed commands. Very useful. That's not nicer. Let's try mode box. Okay, that has potential. I just need to do one more thing. Instead of selecting all, let's select less data so that it fits in the terminal that I want to share with you. So for example, let's select ID, room number, resident name, human name. And that's a very tidy display, I have to say. Mode CSV, I know what it is. It doesn't look nice, but you will see what it is used for. Next one, mode. Okay, not too bad, and this is what they do in the story, but I like POCs. Mode HTML, what's that? Right. Mm. Mm. Mm-hmm. Mm-hmm. Like a box, but no top and no bottom. Q box. What's the difference between box? Oh, that's interesting. So text was taken inside quote marks. That might be helpful. Mode. Mode. Oh, table. Nice. I like table. Tabs. I like table most. Yeah, I like this. Let's do it that way. One useful remark here is the case sensitivity issue. So as you can see, sometimes I'm typing in uppercase, sometimes in lowercase. Does it matter? Sometimes it does, sometimes it doesn't. Here in SQL, it does not matter how I type my commands. In story J, when he was learning, he was also just typing like this in lowercase, and it works just fine. I can select exactly the same thing with lowercase. You know, for example, I'll just change one of them to lowercase. It works the same. And the reason why we use uppercase is just to distinguish between SQL reserved words and everything else. It's just for visual clarity. But in SQLite commands, actually uppercase matters. I will show you. So if I ask help in the lowercase, it works. But if I ask it in the uppercase, it's not going to recognize it because SQLite sees uppercase and lowercase as different things, whereas the SQL doesn't care, except in strings, but let's leave it for now. My point is, uppercase and lowercase case sensitivity is something you need to watch out for and learn about it and get good at it. Okay, let's clear this. So if this was our typical way to look up the data, never mind that it's broken now, eventually when we need to work with it, we select not everything from the table and just the first 5 rows. We actually need to select exactly what we need. So specific columns and specific rows. To select specific columns, we already know because we already did it by specifying, instead of a star, specifying the names of the columns. In our case, it was ID, room number, resident. Let's see, that's enough for now. So that's how we select the columns that we need. And now how do we select the rows that we need? For that, we use the where clause. I'll show you. We don't need the limit anymore, but now we use the where clause. And in where, we specify the condition that the rows need to meet in order to be shown to us. So for example, I want to see the rows where the room number is 301. And that's just that. And now I'm being shown 2 rows in total. So there were 2 stays in room 301. We can combine conditions. So for example, we can add room number 301 or room number, let's say, 101. And then we get all stays in room number 301 and all stays in room 101. While in English language I'm saying and, but in SQL, to be correct, you need to say or, because logically no one can stay in both rooms at the same time. That's why we cannot use the and. So also pay attention to these things in order to combine things correctly. I know they say that now we will be coding in English language soon, but there are these and or things that you need to get them right. Now we used the condition that was an exact match. So we wanted stays where room number was exactly 301. But often we cannot provide an exact match. Often we want a similar match, especially when it's about strings. So for example, in the story, Jay was looking for a cat with the name Princess, but cats have longer name and the word princess is just part of that name. So what happened is when he was looking for an exact match, he was getting no result. So particularly he was looking like this and nothing. Then you use the operator like instead of equal. You know what? Let's break down that into 2 parts just so that you can see better. And I can do that. I can just press enter and continue my query on a new line like this. Where? Resident name. Now I write like this. Like, then princess. Now we also need to use wildcards. And the one wildcard that you need to know, and it's used most frequently, is the %. And it means that before princess, we can have any number of any characters. And after princess, we can also have any number of any characters. Let me show you what I mean. Here I executed it and I'm getting all stays where princess was a part of the name, and we can have anything else either before or after princess. There's one more wildcard, but it's actually used very rarely. It's an underscore, and underscore means not any number of character, but one character that is any character, but only one. But typically at work you use percentage, and this is a very typical way of searching. Now you know how to find the data that you need, but you can only get data from one table. Next in the workflow, very often you will need to combine several tables into one result. How to do that, I will show you with an example. So let's just clear this. Say we have 2 tables. One table is our, and the other table, extras provided. And let's limit it to our filter using the where clause. I think it was this. Yes. So here are 2 tables. So here we have the table of extra services provided during this one stay. But we only have the ID here and the price. We don't see here what is that service, and the description of those services are in this table, and what connects them is this ID. So for example, here's the extra provided with the ID 201, and it has cost 4,020. So we find that ID here, and that's a robotic squirrel chase. When I'm making a report, I want everything in one table, not scattered around separate tables, and for that I use join, and I use it like this. Let's take our previous code. Here we are selecting from one table. Let's select from two tables. From extras provided, left join. It can be left, it can be right, never mind right now. Left is the most frequent join. And what it means is that the table on the left is the table that we want everything from. So we want all the rows from the left table, and then we want the matching rows from the right table. That's what this left really means. Okay, so the name of the second table is extras. Now we need to tell what is the commonality between these. In extras provided is the extra ID. So on extra ID has to, so this extra ID has to equal this ID. Let's see what we get. And we get our extras provided here on the left, and then on the right we have connected these descriptions to the matching extra services provided. Here you can see that in this row 201 and 201 repeats twice. It's because this is extra ID in our left table, and this is ID coming from our right table, and they have to match. And the same is true for all the rest. Now, to tidy this up, we don't want these IDs to be repeated. So then what we do, we select only the columns that we need. So let's say stay ID is not interesting, it's the same everywhere. Let's leave the ID just in case if we need traceability. Let's leave the price and description. And now we get a nice table where we can see it all in one place. There's a lot more to learn about joins. Like I mentioned, there's left join, there's right join, there's inner join and outer join and so on. But I can't cover all of this here in this video. Now that we have these nice results, we need to share them with whoever needs them in the first place. And typically that is done as a file, often as a CSV file. How do we do it here? This is not specific to SQLite, but I will still explain it. I think it's pretty cool. These are the results that we need to share, and this is, let's call it our output. And SQLite works like this. When I execute this statement, it gives me the output into whatever is specified as the output destination. So currently the output destination is here in my terminal. That's why when I execute this, I get output right here in the terminal. But I can specify the output to be a file. Let me show you. I just type output and then specify the name of the file. Let's make it like this. When I execute that, now SQLite knows. Next time I need to output, I do it into this file. So when I execute this sentence, I will not see anything here in the terminal. It will appear as a file. Okay, you can already see the file is created, but the file is empty because I have not executed this sentence. But when I do, it still says 0 bytes, but you see that there is already content in there. So if I open it with, let's say, text edit, you can see exactly the same thing that we had here in the terminal, but it was sent into a file. Now, I wanted a CSV file, and this is not a proper CSV format. This is not going to open with a, you know, actually want to open it with Excel, or if I'm on a MacBook, I would like to open with numbers, but this is not going to work because numbers does not recognize. Okay, actually, it did recognize the format. It's a little bit ridiculous though, and people are not going to take these results seriously, so let's do it properly. But it's nice that it tried. Okay, let me quit it and do it properly. So first, I need to change the output mode. Remember how we were doing these mode things? And when I changed mode, I got output shown to me differently. And there was a mode called CSV. So for now, let me show this in the terminal by redirecting the output back to where we can see this in the terminal. And I do it like this. Command.output and then std out, meaning standard out. When I do this, I will get the results here back in the terminal. Now I will change display mode. Let's change it to CSV. Let's see how it looks. And you see it's a little bit ugly, but that is the CSV format, all separated by commas. This is what is needed to make the CSV file. So now let's change the output to, let's call the file proper output CSV. Now you can see that file got created there. Let's execute. And so you can see it there. And now if I just double click, and numbers will open it, and now it reads everything correctly. This is my CSV file formatted properly. The last step in the workflow was to do some finishing touches. What I mean by that is that you need to make the results look more human readable. So for example, the column names sometimes can be renamed. Unnecessary columns can be deleted. And then also some cleanup in your working environment. So for example, if you created a bunch of empty files or the intermediary results, you might want to clean those up. And at the very end, also, once you have sent the results over, you need to set everything back like it was. So for example, here, I would make the output like it was, standard out, mode back to, it was a table, I think. And then to exit everything nicely. So from SQLite, we exit by typing .exit. And then to exit the terminal properly, we also type exit without the dot this time, like that. And then as the very final step, I would recommend to document the steps that you did somewhere, so that if a similar request comes in, you don't have to do everything completely from scratch and remember what data was where and how did you join everything, but that you can just look up how you did it last time and do everything in the same way, and it will be faster. Let's do a quick and short summary of all of this. So the whole point of the video was for us to understand the typical workflow of a data analyst, or perhaps some other person who also needs to find some answers using SQL. And the value of knowing that is that when you know what kind of SQL is being used most frequently, then you can focus your learning on those parts of SQL. Then it will have a huge impact on your day-to-day work. You will get better and faster. Have a nice day and see you later.